In the previous video, we have mentioned that if our force is conservative, we can interpret the work done by the conservative force in a different way. To be more specific, we mentioned that the work done by conservative force is equal to the negative of the change of potential energy. So we know that we'll see two types of conservative force in chapter 5. The first one will be weight or gravitational force. So in this video, we'll study or analyze various situations in which we find the work done by gravitational force and relate it to the change of gravitational potential energy. And in the next video, we'll look at the second conservative force, which is the restoring force by the spring. So for gravitational force, we know that the work done by gravity is equal to the negative of the change of gravitational potential energy. So what are we going to do now is we'll analyze two different situations. One is a situation in which the work done is positive, and the next situation will be the work done by gravity being negative. What are we going to do? We are going to prove that for work done positive or work done negative, this thing is always being obeyed. Okay, this is always true no matter whether your work done by gravity is positive or negative. So a scenario in which the work done by gravity is positive can be a situation in which an object is falling. So an object is initially at somewhere at a higher altitude, then it falls to somewhere which is at a lower altitude. So we can expect the displacement to be a downward vertical displacement. So the initial position is at somewhere of higher ground, so Hi will be a larger value, and the final position will be somewhere at a lower altitude, so you should expect the Hf to be smaller than Hi. So our focus here is to determine the work done by gravity, so we need to determine the weight and the displacement. The weight here is pointing downwards because that's gravitational pull exerted by the Earth. The displacement is also pointing downward because this is an object falling. So if you want to determine the work done by gravity, we have to determine the magnitude of the weight, the magnitude of the displacement, and multiply it with cosine of 0 degree. 0 is because the weight and the displacement are pointing in the same direction, pointing downwards. Again, the magnitude of weight and the magnitude of displacement must always be positive because they are both magnitude of vector, and magnitude of vector must always be positive. So the magnitude of weight is just mg. This is what we learned from chapter 4. And the magnitude of displacement here is something which we might need to be more careful about. Again, the magnitude of displacement must always be positive. Our aim is to make this magnitude of displacement positive. So to make this magnitude of displacement positive, we have to take the larger value minus the smaller value. Okay, it's always this way, take the larger minus the smaller. Our aim is to make it positive. We don't care about the direction, whether it's going downwards or upwards. We just need the magnitude. So we are taking H initial minus H final here to represent the magnitude of displacement. So let's expand it. You have your S being represented by Hi minus Hf, big minus small, whereas your cos 0 degree here will be equals to 1 based on trigonometry. Now if you expand it, you have mgh initial minus mgh final. So this is the initial gravitational potential energy minus the final gravitational potential energy. Okay, we are reached here. We know that this view can be easily being manipulated to become this form over here. What we do here is just factorize out the negative sign, and now it will be final gravitational energy, potential energy minus the initial gravitational potential energy. And this part here is just delta gravitational potential energy. Okay, so we have successfully proved that if our work done is positive, we can change the equation from the normal work done equation to prove that it is equals to the negative of the change of gravitational potential energy. Okay, so now let's analyze this situation that we have here more qualitatively. Okay, so the work done here is a positive work done because the weight and the displacement are pointing in the same direction. So this is due to the fact that cos 0 degree here is a positive value, positive 1. Therefore, we know that positive multiplied by positive multiplied by positive will be a positive work done. So work done by gravity is positive, and because we know this relation here, we know that if our work done by gravity is positive, the change of gravitational potential energy must be negative, because negative multiplied by negative will get you positive work done by gravity. So you know that the change of gravitational potential energy is negative, and change of gravitational potential energy is negative, means that the gravitational potential energy actually decreases because the final is now smaller, whereas your initial is larger. So final minus initial, small minus large, will become a negative answer. Therefore, your delta gravitational potential energy is negative. Okay, so that makes sense actually, because as you see the object falling, you know that the gravitational potential energy decreases because the gravitational potential energy is being transformed into kinetic energy, causing the object to speed up while it falls to a lower altitude. Okay, so this is our analysis of the situation in which the work done by gravity is positive. Now let's move on to the situation where our work done by gravity is negative. Well, work done by gravity is negative is similar to the previous video on gravitation, on where we prove gravitational force is a conservative force. We have a situation where our object is rising from a lower ground to a higher ground. So this time the displacement is an upward displacement, and our initial position is at the lower altitude, so you have a smaller high h initial. Our final position is somewhere at a higher altitude, so h final will be larger than h initial. So now we want to determine the work done by gravity. We need to determine the weight and the displacement. The weight is as usual pointing downward, but this time our displacement is now pointing upward. So the weight and the displacement are pointing in opposite direction, therefore the angle between them should be 180 degrees. Again, the magnitude of weight is just mg, but for the magnitude of displacement, our aim is to make the magnitude of displacement positive. So always take the big one minus the small one. In this case, big one is hf, small one is hi. So we replace this magnitude of displacement here with hf minus hi. Always make this positive. So mg multiplied by hf minus hi, then we know from trigonometry that cos 180 degrees is just -1. So now if you expand everything, you should get negative final gravitational potential energy plus initial gravitational potential energy. Now if you factorize out the negative, then you get it's just negative bracket the final gravitational potential energy minus the initial gravitational potential energy. So what we have inside a bracket here is just a change of gravitational potential energy. So now we see that even if our work done by gravity is negative, we can still come to the same conclusion that the work done by gravity is just equal to the negative of the change of gravitational potential energy. So we see that even no matter whether our work done by gravity is positive or negative, it always follows this equation that we have here, where the work done by gravity is equal to the negative of the change of gravitational potential energy. Okay, so now let's analyze this situation more qualitatively. So in this case, we see that our work done here is a negative work done. Why? mg is a positive, s here is also a positive because they are both magnitude of a vector, but cos 180 here is -1. So positive multiplied by positive multiplied by negative, you get a negative work done by gravity. So cos 180 here, 180 here is the one that caused our work done by gravity to be negative. So if our work done by gravity is negative, we know that if it's negative over here, our change of gravitational potential energy will have to be positive. Then negative multiplied by positive, you get a negative answer over here. So our change of gravitational potential energy will be a positive value. So if our change of gravitational potential energy is positive, that means our gravitational potential energy increases. Well, if you look at this situation, it actually makes sense as well. Because if you are throwing an object upwards, the object will gain potential energy. So the kinetic energy will be transformed into potential energy to be stored in the system. So you can see the object will be slowing down because kinetic energy is being transformed to potential energy. So potential energy increases while kinetic energy decreases if you are throwing an object upwards. Okay, so we have successfully proved that no matter whether our work done by gravity is positive or negative, we always follow this equation in which the work done by gravity is equal to the negative of the change of gravitational potential energy.